Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. The first Tuesday of every month we try to do a session for absolute beginners, and so that's what tonight's session will be, and we're going to be looking at f-strings, which is a way of creating formatted text. We're going to be doing it with using Datalore from Jetbrains. Now normally we use Google Colab, but Google Colab is stuck on Python 3.7, so we're going to try using Datalore tonight, which will gives us the facility to use Python 3.8. So some people will be needing to create a new account on Datalore to be able to do this. Okay, so I've created a link here. So this link is in the is on the Meetup page. It's also on the YouTube video. You can chat with me during the presentation on Slack, or so there's Slack, or you can also chat in YouTube chat. So I've got a little window here that tells me what people are saying on YouTube chat. Alright, so let's open this link, and that'll take us off to Datalore. Now I haven't got an account yet, so I'm going to create an account for this account. So let's sign up with Google. Now these notebooks are a great way of learning Python because you don't need to install Python on your computer, and it's great for following along because we can just do it one part at a time. It doesn't have to run the entire Python script. So let's see, accept and continue to Datalore. Alright, so setting up that account was pretty easy. And it's given us a copy of the notebook that we're going to be using in tonight's session. So the first thing, let's see, they've got a few tips here for us. So you can click here to upload files. We won't be uploading anything tonight. Managing your environment, you can choose which libraries you want to use. Share and collaborate. I'm not sure what's even pointing to for that. Okay, so this is our notebook, and the first thing you want to do is clone it to your home folder, and that way you can make changes as well. And there's our cloned folder and our cloned notebook, and now we can I'm going to share this one with you as well because I might make changes to it as we go along. So I'm going to click on share. Now I don't use this one a lot, so it's going to be interesting how we go. So I'll give you a view access link to this one. Anyone with the link can view the notebook. That sounds good. So I'll copy that and I'll paste that into Slack, and I'll paste it into the YouTube chat. If I can get the YouTube chat to work, maybe I have to use this one. Okay, so I've pasted that link into YouTube chat, so that will give you the one that I'm making changes to tonight, or the original one is just the one with no changes. Okay, and that's been published. Okay. Alright, so these are Jupyter notebooks, and they're made up of cells. So you can see there's a box around this cell which explains what we're doing, and that's called a text cell. We can have code cells and text cells. So this one here is a code cell, and you can see it's got a play button that we can use to run the cell. So I'm going to click on that, and when it runs it, it tells us this is just the way to work out what Python version we're using, and it's version 3.8.12. At any point we can insert new code cells, or there's other cell types we can insert any of these sort of cells. So these markdown, I've used markdown and code cells tonight. Alright, so we're going to be looking at strings. So string is a bunch of text. It's like it's a string of characters. And you designate a string in Python by putting quotation marks around it. So here's the word hello, and it's got the single quotation marks around it. And now if I click on the play, it'll say, yes, you've got a string, which is hello. Now there's things we can do with that. We can assign it to a variable. So if you've done any programming before, you'll know about variables, or places where we can store data. You just give the variable a name. I've just called it s here, and I'll say s equals and what I want to store into it, which is the string world. Okay. These lines here have got a hash sign at the front. They're comments, so they don't actually run anything, and I've just put them in so you can see what's going on. So here we're going to assign a string to a variable, and the string is world and the variable name is s. Now to display the contents of that variable, we can use a print function. So I ran that cell. I actually pressed Shift Enter that time, or I could have clicked on the play button, and down below the cell is the results of running this short little program, and you can see world is displayed here, and it's displayed it without the quotation marks. That's just converted the string to our output text. Now we're using Ipython here, so Ipython's got everything that Python's got, plus it's got this ability to run in cell by cell. And they're called Jupyter Notebooks is what the new name for Ipython is, and it's what Google Colab uses, and it's what Jetbrains Datalore is using. Now we can put the variable name just as the last line in one of these cells, and whatever the result of that expression is on the last line, Jupyter Notebooks will display the result of that, but it displays it here with quotation marks because it's telling us clearly that this is a string, but we don't want to see the quotation marks. So for the rest of this session I'm going to be using the print function to display our strings. So once again, here we can display a string hello world, and there's our result. Now hopefully sorry, I didn't mean to do that. Hopefully you're able to follow along and are able to run the cells in your Datalore account. So let me know if you're having any problems doing that, and I'll just keep going until someone says something, and then I'll go back and we can review where you're having trouble. There's a couple of ways of using the print function. We can put variable names into the parameters of the print function, and here we can print what the value of C is twice just by doing C, C. So we put New York into the variable C and we print it, we get New York, New York. And you'll notice that there's a space in between those two strings. So that's what print will just do by default. If you don't tell it to do otherwise, it'll print the values with spaces between them. Now if you remember from other times when we've played with strings, or if this is your very first time, we can add strings together using the plus operator. So here we've got a string that is the letters for hello and a space. Then we add it to a string C, which remember has got New York in it. Then we add in another space and then another string, and we C, which is New York. So we're going to save all this into a new variable called D, and then we're going to print the results of D. There we get hello New York, New York. So extending the mathematical metaphor, if for plussing we can put some strings together and add them all up. We can also do multiply, which is not something I've seen in any other languages. If you multiply a string by a number, it'll do the same string that many times. So it's like doing, in this case we've got a dash as our string, so it's dash plus dash plus dash plus dash plus dash up to 40 times. If we store that in a variable, which we'll call dashes, then we get our 40 dash signs, or minus signs. Alright, so the string doesn't have to be a single character string to be multiplied. So we could do a 3-character string, for example, dash pipe dash, multiply that by 40 times and print that, and you'll get this sort of pattern. So you can see there's the first one, there's the second one, there's the third one, and there's the 40th one. Okay, now I'm going to give you some challenges here. So here's our first challenge, is print a string of 50 underscores. Okay, so we can do like we've been doing before. We get a variable and we'll say we'll have a string with an underscore in it, and then we'll multiply that by 50, and I'll press enter, and then we'll print the value of u. So when I'm doing these challenges, you can pause the video if you want and have a go at it yourself, and then play the video to see the solution. Maybe put it on a bit faster time so you catch up to us. And there we go, printing 50 underscores, and there they are. Now I'm going to do the solution for you, but I'm also going to provide, there's also a solution provided here, and normally in these solutions I'll give you just a few variations on the way you could have done this. So things to note in this solution, whereas Annie obviously did that one well. She said it was too easy. In this solution we're using double quotes rather than single quotes, so they're just equivalent. You can use single quotes or double quotes when you're doing Python strings. Also when you're using multiply, you can put the number before or after the string. So here we did the string times 50, and this time we did 50 times the string, and if we print it we get the same result. Okay, so and the other thing that we did differently here is we put the expression straight into the function. We didn't bother saving it into a variable first. So that's another way of doing it. Okay, so our second challenge is to print the following line: Python wasn't built in a day. So let's try that. We'll use the print statement. Now if we used single quotes here and put that into our string, you'll see that Python started the string here at the first single quote, and then kept going until it got to a single quote, and then it goes, well, the string must be ended, and then the rest of it goes, what is that? Is that something else? Then and this is where it's an advantage to use double quotes. So if I change that to a double quote and a double quote there, then I can use a single quote within my string without Python thinking that we've come to the middle of the end of the string when we're actually only in the middle of it. And there's our solution. Okay, so I'm getting a couple of here. So Annie said the first challenge is too easy, and Leo says try doing it in fewer characters. Can it be short? How short can it be? So that's the challenge for Leo. See what he can come up with. So this our solution here is really we've covered everything already in our solution. Alright, so now let's introduce f-strings. So these were just normal straight strings, but the real topic for tonight is f-strings. Now f-strings were introduced in Python 3.6 and they've quickly become a very popular way of formatting data in strings. And the way they work is when you create your string, it'll be single quotes or double quoted string, you just put a letter F out the front. And then what it will do is it'll look for any times you've got these curly braces, and rather than printing CITY, it'll evaluate this expression and put the results of that expression into the string. So here we're saying city, our variable called city has got the city name Brisbane in it, and then we said S equals teaching about f-strings from sunny city, and when we print S, it's substituted Brisbane into the string because Brisbane is the value of the variable city that it's evaluated. So that's a very easy way to combine the dynamic nature of variables into the static nature of static text here to make a full string. Now that expression, it can be a string variable, or it can be a you can also have numeric variables, and it will convert the numbers into a string. So for example here, tonight we're doing Meetup number 145, and so we'll store that into our variable called Meetup, and when it evaluates this, it now puts the digits 145 into our string to produce all the text that you see there, and that's all as text. So 145 has been converted from a number into text to create that string. We didn't save this one in a variable, so once it's been used, it's just forgotten. Okay, so challenge 3. Calculate the quotient and remainder from dividing Meetup number by weeks per year and display in an F string. Okay, so I've already told you what the Meetup number is 145, and I'll give you a variable here which has got how many weeks in the year in it, which is 52. So we can say our quotient equals, we take the variable Meetup and we use integer division to divide by weeks per year. And our remainder, I'll store in R, equals the same equation, but this time we use the modulo operator, weeks per year. And what I want to do, display that in an F string. Okay, so let's print our F string, and we'll just say our quotient is going to be the number of years, and our remainder is the number of weeks that aren't in that number of years. Import. Okay. So what the problem is that I've done here is I forgot to run this cell here with the challenge in it, and that's what assigned the value to weeks per year. So I'll go back up to that cell. This is another advantage of these Jupyter notebooks, is I can run the cells in any order, and in fact it tells you the order we've run them. So you can see 15 was run, and then 16, and 27, that's from the last time I was working in this notebook. So I run it again, now it's number 17, and now I want to run this one again after I've run number 17, and it says 2 years and 41 weeks. Alright, so let's have a look at the solution, and it's got a string here. It says solution 3, then a new line, beginners Python and machine learning has been running for 2 years and 41 weeks. So the way that we put a new line into the string, this is really a string thing rather than a f string is we use this escape character. So backslash is the escape character. We've escaped the n to say don't use your normal meaning of n, which is just the letter n. We want to use the special meaning, which is new line. So backslash n gives us a new line, and so with that one string and the one print statement, we've printed 2 lines. Okay, so we've got challenge after challenge here. So let's go into challenge 4. Print the powers of 10 from 1 to 1,000,000. And the hint, 1,000 equals 10 to the power 3. So that's how you do 10 to the power 3. Okay, so we don't know how to do loops at this stage. So I should just say, so I could just do print statements like this, but that's not really using f strings. So the first power of 10 is 10, second power is 100. So let's put them into f strings. So we create a string, we start it with an f in front of it. Then we don't really need to enclose the 1 because it'll just print out exactly as it is. But we want to evaluate 10 to the power 1 and then print the result of that. Similarly, we'll do 2. Yeah, that's nice to know. So I could select that text and I did the left curly brace and it put a right curly brace around it, so that was very convenient. So let's we're going to 1,000,000. Alright, so there's our powers of 10 up to from 1 to 1,000,000. I could have done 0 at the top. And there we go. 10 to the power 0 is 1, 10 to the power 1 is 10. Alright, let's have a look at the solution. Now, solution is giving us, showing us how to do a loop in Python, and we use the for loop. So a for loop is says run anything that's indented this number, the number of times as number of elements are in that. And so in range 7, there are going to be 7 elements going from 0 to 6. And every time through the loop, it's going to store that value in the loop variable I. Okay, so Annie's asked, does Datalore automatically save? I am pretty sure it does, but I'm not going to guarantee that. But yeah, obviously I haven't. Well, there we go. We're going to find out. I've gone back, and now we'll go in, and we'll see that all these things that I've been running, they're all here. So yes, it does automatically save. And so if any of you have got the link from before here, you might find you can refresh this. I'm not sure what Open Original does. Let's try that. And that's got my changes in there. Let's see, we'll go down to the challenge. Yep, there it's got my changes in it. And they're all refreshed up to here. So yeah, if you're following along in one of these, you can refresh the link that I originally sent you and you'll get all the updated changes that I've made. Okay, so we've got this for loop, so that made it easy. I just had to do the print statement once, and I just put I into there, and so it evaluates I. I've been a bit nicer for the reader. I've put 10 asterisk asterisk I, so I can see what is actually going on rather than just 0, 1. I put 10 to the power 0 is 1, 10 to the power 1 is 10, 10 to the power 2 is 100. And now another nice thing that I've done is I've lined up all the units. I've lined up the tens, the hundreds, the thousands. So that, and the way I've done that is I've put in a format in our format string. So in your curly braces, you can put a colon, and anything to the left of the colon is the expression that gets evaluated, and anything to the right is the width, is how you want it formatted. And in this case, we've put a number, and so the number tells us what width we want to do. And for because the results of this expression is a number, when we could put in a width, we assume that it's going to be right aligned. So it's done all that work for us. That would take us a bit of coding if we wanted to do that manually, but our format string's done that nicely for us. Okay, so challenge 5, given that a mile is 1.6 kilometers, print a conversion table of the form 1 mile equals 1.6 kilometers, 2 miles equals 3.2 kilometers. All right. So let's see what happens if we just, let's just create our for loop. So we'll say M, and that's going to go from 1 to 10. So remember before we went from 0 to 6 by using the range, but range actually gives us the ability to give a start number, which we want to start at 1, and then we go up to the number that we don't want to get to. So it's we want to go to 11, or we want to go to 10. So the last time through is going to be 10, so we put in one more than that, so it'll go up to, but not including the last value. And the reason they do that is that it makes it clear how many times it's going to go through the loop. It's going to go through 11 minus 1 times, which is 10. So that's, and each time it's going to have a different value. All right. So we want to put in our number of miles, and we can see we just want that right aligned with a space with. So I would say width of 2. And how many kilometers is that going to be? It's M times 1.6. And we'll make that a width of 1, 2, 3, 4 characters. Kilometers. Okay, so let's display that. So that's looking pretty good here for our number of miles, 1, 2, 3 up to 10. But you see we're going to have some problems here on our number of kilometers, and this is caused by floating point rounding errors. That's common in just about all programming languages, is they store these decimal numbers in a binary representation that can't exactly store the number. So you're going to get some of these rounding errors when you start doing operations on them, like multiplication or addition. So we've said we want it to be a width of 4 as a minimum, but that doesn't say what the maximum width is going to be. So that's not going to look great in our output. So let's have a look at the solution that's provided. And we'll see what it looks like, and that's looking a lot nicer. And so we'll have a look at how the format works here. So once again, on the format for our integer number of miles is just the number 2 to say use 2 spaces. But our format for our floating point number here, we've said we've given a width 4, we've given a dot to say we want to use decimal points, and the number of decimal places we want after that decimal point is going to be 1. And we've put an F to say we want to use fixed number of decimal places. And so there's a lot of these little formats that you get to learn as you use f-strings more and more, but it's a fairly common one, converting float numbers to a fixed number of decimal places. And so that looks quite good. Okay, so I thought I'd list here some of the different formats that you can use. So for this F, so we've got, for floating point numbers, you can use F for, they should actually say fixed floating. It's a floating point number with a fixed number of decimal places. E is exponential notation, and there's another one, G, which is floating point. You can sort of mix between the two of those. D, for integers, we can use D for decimal, so that's base 10, like these. So we could have put a D after the 2. That's the most common, that's the default. But we can also do binary, octal, hexadecimal. So if you need any of those, you can even do capital X for hexadecimal in capitals. So here's our same thing using a number of our number of miles in decimal, our number of miles in binary, which is just ones and zeros, our number of miles in octal, which is goes up to 7, and then 10 is effectively 8, 11 is 9, and 17 is 15. So that's octal is base 8 basically. Hex, which is base 16. Once you get past 9, we start using letters. So A for 10, B for 11, C for 12, D for 13, E for 14, F for 15. And you can do that in capitals if you want capital letters instead. Okay, now let's have a look at our floating point results. These ones look the same as before using the F. But if we used an E, we can use it to get this exponential notation, which is useful in some times. So 1.6 times 10 to the power 0. Or once we get above 10, we look at this. So 11.2 is the same as 1.12 times 10 to the power 1. So exponential notations are a good way of displaying very big numbers, and it's used by scientists quite a lot. Okay, so we're going to do some more exercises, but first of all we'll get some data. And so I thought we'd go to the Brisbane City Council Open Data facility and grab some data they've got there for ferry terminal locations. So if you hold down the control key, you should be able to click on these links that I've got here, and they'll open up in a new tab. So this one is on their data.brisbane.queensland.gov.au site, and it gives all the ferry terminal locations in a CSV file. So if we look at what the data looks like, we've got the Data Explorer, and that's pretty much showing us we've got X and Y, that's an easting and a northing, and a bunch of stuff, the street address, where it's adjacent, what suburb it's in, etc. Now they've also given us this data API, which makes it easier for us to get the information programmatically. So that sounds really good. Let's have a look down here, and they give us some examples of how to do this, and there's even an example in Python. So let's have a look at this example in Python. So we want to import this library so we can use it to grab the data straight from the Brisbane City Council website, and we're going to open that URL and read the data and print it out. Alright, well, I copied this data before and put it into our notebook, and I've put it here, but the problem with that data is that it's Python 2 code. So you're going to come across Python 2 code even now, even though Python 2 is really end of life and shouldn't be used anymore. But there's still people who are publishing Python 2 code like the Brisbane City Council. One of the ways that you can really spot that it's Python 2 code is their print statement doesn't have parentheses around the thing that's being printed. So in Python 2, print was one of their key words. In Python 3, it's just a function, and that by being a function, we can it's beneficial to us, but people who got used to using it without parentheses didn't like it very much. And that's probably one of the major reasons Python 2 stuck around for so long. And anyway, if we wanted to convert these lines of code here into Python 3, and I've just commented these ones out so they don't throw errors, the URL lib has changed. So you now want to get URL lib.request to make this sort of request, which is opening a URL. The URL is going to be the same, although I've noticed that in their example code they put this query string at the end, which is saying we only want records which have a title called Jones, but of course none of the data in very terminal locations has got a title called Jones, so we'll get rid of that, and we'll just put our limit of 5 in our URL. So we're going to get use URL open just like before, and we're going to read that data and print it out. Alright, so let's run that and see what we get. And this is the result. Now it's actually JSON, which is a popular format for data APIs, and you can see it's got a B out the front. So remember, our F strings have got an F out the front. This is a string. There's a quote there, and before the quote to say it's a string, they've put the letter B, which means it's a byte string rather than a Unicode string. Once again, this is byte strings were the default in Python 2, but for any time you do URL opening data from websites, you will get the data back in as a byte string, and you'll need to convert it to Unicode to be able to use it properly. So that's what it looks like. It's a long string of data. It's pretty hard to understand. So I've rewritten this short little bit of code, a better way to write it, and I've used some other libraries. I've used pprint, which stands for pretty print, to display the data a bit more nicely, and I've used the Python built-in library JSON, a standard library JSON that can convert this string of this format into a dictionary using a JSON formatter. Alright, when we open, we won't go into this too much detail. This is a bit advanced for absolute beginners, but basically I read in the bytes, I decode it to Unicode, and then I convert it from a string into a dictionary using the JSON format, and I've stored that dictionary in a variable called dict_full, and then I pretty print that so we can see what it looks like. So I'll run that, and you should be able to run that on your computer as well. So we're all going to hit the Brisbane City Council data center at the same time to get this data, and you can see what it looks like. So I'm going to scroll right to the top, and this is the JSON that's come back. So it's given us a help link and then the result. So it's the result we're interested in. The result's given us some links. If we wanted to go paging through the data, and it's also told us what fields we want. We're not really interested in that. What we're interested in is the records. So the records are the data that we need. So we're going to, and you can see the records. There's a square bracket there. That means it's a list. And inside that square bracket, we've got lots of records, and each one is enclosed with curly brackets, curly braces, with keys and values. So keys are your field names, and their values are to the right of that. So the accessibility is for disabled access. The number of boarding gates is 3, and a whole bunch of other information. So there's the end of the first record. I see we've got an ID number, and here's the start of the second record. So it's the same data repeated for another ferry terminal. Okay, so there's our data. We're going to try printing that out in a nice way. So the emphasis here is on F strings. It's not really on dictionaries or reading data APIs. So we can get the records out of the our dictionary by using this is how you access data out of a dictionary. You use square brackets and then the key that you want. So we want to go to the key result, which is also another dictionary, and then we use the key for that, which is records, and that'll give us a list of records. And we could just print those out one by one. So let's have a look at what they look like. And there it is. It's each one has is showing a dictionary on one line of the data that we've got. I also changed the URL so that we're no longer limited to 5. So I've got all the ferries here. Let's have a look at the URL that I used. I took out the limit 5 and I put in a query to say I wanted it to be active. So I've just got the active terminals. So you'll see there's a few missing in there. So ID 7's missing, ID 15's missing, so they're no longer active, those terminals. Okay, challenge 6. Print the ferry terminal description, latitude and longitude to match the following title row. Okay, so Leo and Annie having a little competition to see how they can write exercise 1 in the fewest number of characters, and Leo's gone for putting the string inside the print parameters. Okay. All right, so if I run this, that prints our headings for our table, and so I'm going to print that again in my answer. So I'll copy and paste that, and then I'll go through each record. And so I don't use range this time because I've got something that will provide me a sequence of values, and so I don't need a function to provide that sequence, and I can, each time through the loop it'll put in the next value in the sequence into variable r. And I'll just use the same print statement. Now I have to indent what I want to be looped, and in here the way we refer to a value in the dictionary is through square brackets and then the name of the key as a string or whatever object type inside the square brackets. Now I think if we look here, the name of the ferry terminal, what am I going to use for ferry terminal? Maybe I'll use the address. Suburb will do. I'll use suburb. Description. It tells us what he wants to use. So here it's supposed to be. Description, latitude and longitude. Okay, so here's our table. We've got our ferry terminal and describes which ferry terminal it is. We've got the latitude and longitude of the location of that ferry terminal. That doesn't look too bad. Let's have a look at our solution. Introducing the right align operator. So we want these numbers to be right aligned, and we can also align these titles off to the right. So after the colon, if we put a greater than sign, which is like an arrow pointing to the right, that's what right align is. Less than sign, which is an arrow pointing left, is left align, and circumflex, which is like an arrow pointing up, will be the center. Okay, and the solution, we've also trimmed the number of decimal places down to 3 to make it look a lot better. Now to do that, you'll notice that the data that came through actually came through as strings. Let's have a look at the latitude and longitude. So see here latitude, and it's minus 27.45, but it's as a string for some reason. So that's a string, so we have to first convert it to a number before we can then do formatting on it. So to convert from one data type to another, you just use the data type name as a function name. So float in parentheses, and then the value, which is looking up the dictionary, and then we can use latitude with a width of 17, so it matches our title width, and then 3 decimal places. Alright, I hope you're going along with these exercises, not getting many questions at the moment. Okay, challenge 7. Print the ferry terminal description, latitude, longitude, pontoon length, and pontoon material to match the following title rows. So, you know, pontoon length was too wide to have as a title, so we've put that onto 2 lines, and pontoon material we've put onto 2 lines. Now, to make it easier to see if we've got the right formats on our first and second lines of our title, I've used format strings where I didn't necessarily need to, but it just makes it easier to keep track. To say I want a bunch of spaces, but that goes up to 35 characters in width, and that way they should all be aligned. So let's try doing challenge 7. So we print our title, then we'll get our records that are going to go in the loop. We're going to print the description in 35, that's right. Latitude in 10, so I better change that to 10. Longitude to 10. And then pontoon length. So let's see. We'll go length equals float and then pontoon length. And what's the other one? Material. Okay. Well, material is not going to be we don't have to convert that to a float, so I can leave that where it is. Pontoon length, and I've left a bit of space there. I can put in meters, and then pontoon material. And we'll make that centered 10. Now I didn't quite get that right because I put the M out the side here. I should have cut a couple of characters off this one. But let's just have a look at the solution. One thing I'm going to do, just so you can see what's going on here, is I'm going to put vertical bars around pontoon material, and these are supposed to be centered, and the steel's looking pretty centered, but the concrete is looking like it's way off to the left. And I think you'll find the reason that is that when they are telling us that it's a concrete pontoon, they use concrete and they have a space after the end of it. So we want to really strip away those spaces. So if we look in the solution, we do strip away those spaces, and that makes it look a bit more centered. And I've put the meters in close to the pontoon length so that it's and made it one less, so there's room to have the letter M there, and then our columns line up. Now I think there was a question here. Let's have a look. In your for loop, you've opted to list the first 10. What if I wanted to loop the entire data set? That's a good question. Yeah, so if you want the whole data set, just get rid of that slice off the list, and they'll all show. So I was just cutting it down to 10 to make it a bit easier to see. But you can do, with those slicing, you can do other things, like you can, in the slice you put a colon, and before it is where you want to start, and after it is where you want to end. So we could start from record 5 onwards, or we can stop when we get 3 from the end. So there's plenty of fun things that you can do with slicing. So that's 2 from the end. -2 is 2 from the end. Alright. Yes, so, and the other option, as Annie has pointed out, is you can just do a full slice that starts at the beginning and ends at the end. But if you just take out the slice altogether, you'll get the same result. Okay. Alright, challenge 8. So it's the same thing, and we want to put on last inspection date as well. Now, last inspection dates come as a string, so we want to convert the string to a date, and then we want to format the date using string format time. Okay. So let's grab our code, put it in our cell. So we're going to add in last inspection date. We don't really care how wide that is because it's at the end. And we have to do this. So there's an example of parsing the time. So we're using this standard library. We use the function string parse time to parse it, and we want to trim off the last 3 characters. And the reason we're doing that is because the last inspection date's a really weird format that I've never seen before. +00, so they're obviously trying to do some time zone thing. I don't know how they'd put Adelaide time zone in that, but it's all zeros, so it doesn't really affect us. So I'm just going to trim off the last 3 characters, and I'm going to use that slicing like we did before, this time on a string rather than on a list. And I'll just say take all the characters except for the last 3 characters, so go up to 3 from the end, and so that's those 3 I'm going to get rid of. Then I'm going to parse it. So here I put in my format. So it's going to be a 4-digit year, a 2-digit month, a 2-digit day, 2-digit hour in a 24-hour format, 2-digit minutes, 2-digit seconds. And then I'm going to format that %D, %B, %M. And so %B, it gives us a month, but it gives us 3 letters. And so you can see there it's coming out as October, even though it went in as 10. All right. So for each row we'll get the date. And what we're going to grab here is our last inspection date from our record. And remember, we have to strip off the last 3 characters and pass that, and then we're going to display, and this is where in so I could do d.string format time, and yeah, let's just put that in there. Okay, that worked. Last inspection, and we're just displaying string format time. Now these strings, this is going to be a fairly common thing that people want to do, is display the date formatted. So you can actually just put the parameters of string format time straight in there after the colon, and it will just do the string in that manner. So let's run that and just see it gives us the same answer. Yes, it does. So we still need to parse the string of the inspection date separately and store that in our D variable. But once we've got that in a variable, it's easy to print it out just by using our string format time parameter string, format string after the colon here. And this, I haven't seen this documented anywhere, but I've seen people start to use it. So it's really useful. Alright, so we're getting close to the end. I've got a couple more little things you can do with format strings that can be useful. So for example, fill characters. Up until now we've just been using spaces for our fill character, but sometimes you might want to fill it with zeros. So for example, that's using space to fill our with our 4 binary number, but we could fill it with zeros just by putting a 0 here just before the character that says how we want it to be aligned. So if you're going to do a fill character, you need to use an alignment character such as less than, circumflex, or greater than, and then it will fill it either on the right or the left based on what character you use. So that could be useful for things like this. Say we wanted to print beginners Python and machine learning and have lots of asterisks either side to make it centered, and so we've achieved that just using a little format string here with a leading fill character of an asterisk. Now Python 3.8 gave us what's called the logging notation, and this is so useful, especially when logging. When you put your variable name in here, you put an equal sign after it, and it'll print the value of the variable plus, or the expression, plus it'll print what the variable name is, which makes it easy for us to follow logging. So in this case, I've got S equals BPAML. I've got I to the power I equals a really big number, and I to the I over 2 is another number, not quite so big, but with decimal places. And the reason I've done these large numbers is so you can see how to put commas between them. After the colon, you just put a comma to say you want the thousands to be separated by commas. You can use commas and decimal points, just put them both there, and 3 characters after the decimal point. Sometimes you might want to have an F string that shows curly braces, but how do you do that? Because every time you put curly braces, it starts evaluating expressions, and the way you do it is use these double curly braces. So I can say the F string F 5 plus 7 evaluates 2, and then the string 12. And finally, a complicated thing you probably hardly ever use, but when you do need it, it's quite useful, is using a variable on an expression on the right hand side of the colon. So we're using expression to determine how it's going to be formatted. So in this case, I want the width of our string to be based on a variable, and I want it to be right aligned with a whole bunch of leading dashes. So if I run that, you can see because I've calculated x from the sine function, I get a sine wave of strings. That's not always the most efficient way of doing it using these format strings. Sometimes you might want to use, I've done it with using plus signs here, not using format strings, the same thing. So I had to take the integer of it, then once I had an integer I can multiply a string by that integer and I get the same effect. Okay, so that's all for tonight. I hope you enjoyed it. Thank you for the questions. I'll just see if there's no questions on the YouTube chat. So all the questions came in through Slack, and that was good. Next week I'll probably be looking at revisiting my Wordle program and seeing if we can make an installer for that, but I better give that a go first, see if I can do it, and if that works, then yeah, that's what I'll be showing next week. So I hope you enjoyed it, and let me know if there's any have any questions. You can ask questions during the week on the Slack channel of anything that you've seen tonight, and I'll try to answer it, or someone else who's in the group will try to answer it. See you later.